1, 2, 3, 4, 5. Hello everyone. Okay, I hope everything's working. Oh, I changed. That's fine. It works. Okay. What we're going to do today? It's slightly improvised and expected stream. Well, all my stream are improvised. I'm not preparing for anyone. For any of the streams. Every time it's pure improvisation, and every time it took 5 hours to write some Zig Hello World, but not this day. I hope not this time. Okay, so what we're going to do? Let me open this stuff. Where is it? So yesterday, let me open it. This one. This nice guy, Valentin Ignatiev, posted actually the great video explaining some low-level basics in C, in assembly. Maybe to just make some laugh about Microsoft code, but also with some educational purposes. So in a nutshell, he just implemented simplified basic version of sleep binary, sleep Unix utility to propose it as a replacement for this safe sleep.sh from Microsoft repository, which is broken completely. But it's fine. Okay. So the plan is today to just follow up on this video, because yeah, it's a great video, but there is some minor issues, and also it showcase for the C programming, C low-level programming. I for last couple of years write most of my code in Rust. So why not to do the same in Rust? Because we can. Rust is another low-level systems programming language. So almost any code written in C can be identically translated into Rust and used here. There is some edge cases for C code which cannot be translated as is. In Rust, it requires some changes, but for this concrete case, it should be straightforward. So let me go. He shared this code somewhere here. Let me check out it first to just make sure that it's still working. Maybe it's broken, maybe not. Because, okay, in one of not buzzword, but a big claim was here that it's portable. It should be portable. I have my x86 laptop, and it also runs Linux, so it should be portable in this meaning. But not sure. Let's try first. Okay. Open my VS Code. Workspace. Let's clone it. Code. Should be fine. Git clone and open code here. Sleep from scratch. Let's go. Yeah. Okay. So what we have here? README. Why it's so slow? Another updates running in background. Oh, Copilot disabled. Nice. Just ignore, ignore. Sorry. So, let me remember how to build it. Let's me. Oh, some reactions. I never seen them in chat. What's going on? Some floating symbols. Okay, if I recall it right from the video, he built it something like this, minus O, let's say, sleep. Let's call it my sleep. Ah, no, it should be fine. Minus O, this one, minus C, sleep C, also my snow leap C, I guess. And yeah, let's try one by one. Okay, it's built. Let's sleep C. Let's try to run. Sleep. Permission denied. Okay. Chmod plus X. Sleep. Let's go. Sleep. Something wrong? Why? Ah, minus C, maybe without minus C. Because minus C maybe produced the object file instead of. Yeah, undefined reference tag, blah 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 blah. Multiple definition. Minus no start. No, how it was built. I don't remember all commands. Let me. No main. GCC, no main. How to do that without a main function. Start. No start files. No start files. Okay, and we have this stack check fail. It's for f no stack protector, right? Or just protector, yes. Sleep. Yeah, and looks like it's working. It works. Yeah, nice. It works. Sleep for 5 seconds. Nice. First of all, first issue that I actually commented in Twitter is this. Let's see what's the issue and how it can manifest, if it can manifest. Minus O3. Now I want to run it for 1 second. It works. Nice. Okay, what if I rebuild it with some other option? What is Trillian is used here? In print, okay. What if I build it with minus O2? Try to sleep. Okay, still working. Nice. Maybe minus OS. Still working. Okay. Interesting. Why issue is not manifesting here? But in general, the issue is the following: that strlen is the same name as defined by standard library. Actually, maybe it's not used. No, it's used. Yeah, sleeping 4. We call this print. Oh, it may be inlined. Okay, it may be inlined. It may be inlined. It may be just inlined. Yeah, it may be inlined. Yeah, let's check assembly. Let's check assembly first. So there is some jump. Bye. Jump minus D sleep. What we can see here, what we can find here, a lot of useless frame, raw data, exit start sleep, yes, print, call strlen, okay, that's fine. So if we go here in main, what you can see, call print, is it inlined? And no, it's not inlined. Okay, I cannot show this magic here. Maybe I can show it in Compiler Explorer in general. Maybe not. Cursor. Again, let me check back. Let me check back the strlen implementation. Where is it? I lost it. Syscall3 parse int strlen. Sorry, string. So okay, if I rebuild it with minus 03 and obj dump again, will it show this magic or not? Print strlen. Nope, unfortunately nope. But in general, let me open Compiler Explorer and show. Compiler Explorer. Why it's so slow? No, it's not a C++, please. I want C. Place it here. Place it here. So 3. No, they fixed it. Interesting. Interesting, it doesn't work. It doesn't work for strlen. Interesting. But for mem copy it worked. Let's check mem copy. Okay, doesn't matter. So it doesn't work. That's fine. So we can skip this part right now. Let's do first thing. First thing is, let's try to build it in C++ mode. I want to build it in C++ mode before switching to Rust, just because C++ and Rust has some common issues. And we should see that it stopped work as expected if I build it in C++ as C++ program, right? So how to build it in with C++? We need to just rename it. That's CPP, right? And try to build. Try to build it with G++. build with G++. Without all this stuff. And I got what? No. CPP. Sorry. Yes, and we have several issues. First of all, we have undefined reference to exit and undefined and cannot find entry symbol start. And also we have some bunch of warnings. We can easily fix it. Actually, this may be a reason why. If I already closed it. Sorry. What if I just reopen closed tab? What if I just add this const? Maybe this is why a compiler cannot shoot in our legs. Yeah, what if I just add const here? Again const O2, O3, OS. No. Okay. Other version of compiler. It was maybe in GCC 10. No. Okay, that's fine. Let's go back. So yeah, we need some consts. And try again. Some other play. Okay, const in print as well and in parseInt. Const here. Const in print. What's wrong? Okay, again another const. Nice. So now we have two errors: undefined reference to exit, undefined and start cannot be found. Right? So why? Because in C++ we have function overloading, and function overloading requires some changes in how symbols emitted for function names. It adds some bunch of metadata called mangling rules, right? So now when we switch to C++, we have not just symbol, not just function named exit or start with underscores. It also includes some information about function parameters. So in actual function name, from the C perspective, it's now some kind of underscore, Z, exit, E4 probably. So we need to disable mangling. It can be done easily via extern C. So let's try again. Cannot find symbol start now. Again, the same problem. We need to have extern C. Extern C here. Now everything works, I believe. Sleep. Yes, looks like working. Another fun part, which is interesting for C++, that main function actually cannot be called in C++, but we can call it. Because here we injected inline assembly. If we just try to, let's say, call main again here, but we can, theoretically we can. Not here. Well, just for demo purposes, let's try to call main recursively, right? Arg C, arg V. It won't compile. No, it works. Interesting. Maybe no start files change the behavior. But usually you cannot call main function directly in C++. Okay, we have everything, right? We switched to C++ mode, it works, nice. Now we can proceed with Rust version. It should be easy. I won't create any Cargo project because it's simple snippet. We will call Rust C directly. Why not? Yeah. So if I remove this, multiple definition of start, defined reference, blah blah blah. Only start main. Interesting. Okay, and yet just to double check if we don't have any specific garbage injected by JTX for C++ runtime. Yeah, for C++ has some kind of runtime to handle exceptions, right? To handle exception, let's check nm minus s, I believe. Sleep. What we have here? Yeah, we have some garbage for stack for exception handling. We have exit, we have main, we have start is defined, we have print, and all other stuff defined in our CPP file. And as you can see, it has this is underscore z 5, then function name, and some other stuff for its manglet name for the function. If we return back to the nice C world, we can do that. We don't have any C++ specific stuff here, except this extern C, right? Except this extern C. But okay, let's do this. Okay, if def C, why it's so slow? C plus. Why I experience so weird lags? Who knows? No one knows. Extern C, and if and here same, if def C plus what's going on? Why it's so slow? But why? Google Chrome, let's close this. Slightly better. And if Should be fine now, right? Go. GCC G++ works. Rename to C back. Rename to C. Renamed. And try again. GCC. What? Nice EDs. And now if we inspect again symbols, where is it? NM sleep. Yeah, now we have without mangling. Okay. Interesting. But it's still here. Just in case we need it. Okay. Nice, not bad. Not bad. Lie. Okay, now we can go to the Rust world. Yeah. Great. Sleep RS. Right. Let's start with simple. WebFN main. Right. Start with version which uses std. So first of all, we need to access parameter, compile command line arguments. Let cleararg duration is, we need to access std environment args. It returns some kind of iterator. We need to access ends element first one. It returns optional. We need to expect because we can. Well, not expect. Let's be close to the example we have. Yeah, that's true. Stop. And I even don't have Rust Analyzer running because it crashed. It failed to discover Karga workspace. But here's a problem most likely in OBS. Yeah, in OBS and Google Chrome. I need to close more tabs. Close it. Close it. And close this and close that. Maybe. Yeah, now I have more. So yeah, let's be close to the reference implementation. Good. What's going on with you? Why it's broken? Why can't exit? Okay. Interesting. So first of all, I want to check Rust app upgrade. Upgrade. Okay, it can run in background and we can continue. So sum, if we have this argument, else print ln usage sleep duration sleep seconds, right? And we also need to exit with some exit code, non-zero, but default Rust main doesn't provide us such opportunity, right? So we have to maybe do something like this. Result nothing, and here I don't know, maybe actually some string, maybe. We can return error. To string, something like this. Okay, then we need to parse it as integer. Duration integer. Let's say use32, right? Sleep duration parse. Yeah, I don't have count completion because Rust analyzer is down. It's fun. And it can return error, right? Map error. Map error. Parameter should be integer. To string. Yeah, now we already have the version which is much safer than the original one, because yeah, if we pass here the something which is not a integer, it will be parsed probably as a 0 and silently ignored. Okay, and now we can call std time sleep, or std thread sleep. I don't remember which exactly we need to call. Thread probably. Sleep, and pass here std time duration from seconds, sleep duration int as something. Yeah, now it should be fine. What's going on here? Why it's still loading? Why so slow? Why so slow? Well, while it's still loading, we still can use rustc. Probably latest version will be needed to have access to some newest Rust inline assembly support. I don't know. But right now, to compile the basic version, it should be fine. Rustc minus o sleep sleep.rs. Right. Okay, we have some errors. Okay, we need to return again here. This is what's missing. What's missing? Okay, what we have here? Okay, this one. It compiles. Yes, it compiled. Now we can run it. Well, latest version has everything. We don't need nightly. We don't need nightly. We just need latest version. Latest stable version, I said. Latest stable version. But I also have a nightly version, but we will use only stable one. Only stable. So again, now sleep. Not sleep. Rust c minus v minus version. Yeah, okay, it's just updated. Nice. We can recompile. Recompile, please. recompiled. Please kill this terminal. I don't need it right now. So let's go. Let's run it. Sleep without parameters. What's wrong with this terminal? Well, VS Code added yet another support for AI help in terminal, and now every time when I run some commands, it's flickering and changes the layout. What the best? What the? You saw it, right? Okay. Okay, error. We have error. Nice. We have another error in this case. Nice. Sleep 2 seconds. Works. Nice. We can. No, before it was fine. Before it started provide this access, not access, this support with autocompletion in terminal, it was working perfectly, at least for me. Now this shit happens every time. I don't know. Build with agent. Go away, please. So okay, we have it. Let's check obj dump. Not obj dump, nm. Let's start with nm because obj dump will be insane. Nm minus s. Sleep. What? Whew. We don't need anything of that, actually, but we have it. A lot of Rust generic shit here. Okay, that's fun. You can scroll video to 5 minutes back and see what we had in C implementation. Now in Rust version with safe and nice abstraction, you have all of this. Nice, but we don't need it. Let's start with no main. No main. Yeah. Okay, no main. Actually, here should be exclamation mark. This directive says that there should not be default for Rust nice, safe, and shiny main function. Instead, we have to write extern C main, right? And exactly as in C version, we can provide parameters, right? argc it's integer, right? Int e32, let's say, and also null terminated array of pointers to char star, right? Let's import, well, use core ffi c char. So here we have pointer, mutable, well, actually can be const, right? Const pointer to const pointer to argv to c char, right? And return e32. Actually, not the e32, we need use core ffi C int. And here we have C int. And we need to return C int. Now we don't have this nice iterator. Instead we have unsafe. Actually, our function now unsafe. Extend cfn and also unsafe. Just because we can. And in the newest version of Rust, we need to repeat unsafe if we want to access something unsafe inside unsafe function, but it will be later. So now we can have something similar, but let's do this. So we need strlen, most likely. Or we don't need it. Const. So if, well, I want to transform this array into something more beautiful, and I can do that. Yeah. Let's call it here f unsafe. Unsafe fn main, which accepts args like this. Const char main impl core slice from raw parts, I believe this is the right name for it. argc, not argc, argv and argc as usize. Let's do something like this now. Much. Okay. In case of OK, return 0, exit success, right? Const exit success c int 0 error exit fail, right? Exit fail failure 1. Exit success, else exit fail. Okay, and here we can return error. We still can print because we still not disabled std. Print clip seconds. Here we can again do this map std mem drop. Actually, let's use more convenient thing. Somewhere I saw the nice name for it. It's called toilet operator. Okay, map error. Okay, it's not interesting. Map error, but I want to print that. I want to print error. Inspect. Yeah. Inspect. Error. Probably we have this in the latest version. Println. I want println. Parameter. There should be integer. Mapper treats sleep. Okay, let's try to build it now. Oh, okay, now we have some stuff interesting. Expected FN. Okay, it's just syntax error. They need go in another unsafe external. Yeah, unsafe. Next, why we don't have core? You may be missing create core. Why? Rust core create. Do I need to specify it somehow specifically? No. Okay, maybe until we are not in NoSTD mode, it's not accessible by default, or something like this. No. Interesting. Maybe some parameters should be. Okay. What if I add NoSTD? Will I have access to core after that? Interesting. Yeah. when NoSTD is specified, you can access core. Without it, you cannot access. Interesting. But it should be possible. Because I want to do it one step after another step. I don't want to immediately switch to NoSTD mode. Do we need to pass some parameters to rustc to have access to so if I just search for this error somewhere, can I find the can't find create core. Why? rustc and core create. Can't find create for core. Do you follow instructions for error? Blah blah blah. Should I specify target? Without it, it cannot. Interesting. Okay, which parameters Rust has? Okay, I want to go here, -g, -l, -l, full archive, bundle, create type, edition. Maybe I need to use a specify edition for it. Optimize your code. Indeed, explain, test, target. Because it's strange, core should be accessible, no? Even if we build, if you not specified no std. Maybe some magic parameter should enable it. Because I believe if I do something like this, let me just to check it. Cargo new, let's say binary, test here. So if I just try to import here something from core, use core FFI, let's say this, cd test cargo build, it builds. So there is some specific magic parameter needed to be passed to the to Rust C. Okay. Try to find this parameter. Go away. I don't need this. How to cargo verbose? Let's find it. So if I run it as cargo clean cargo build -- verbose, will we see the parameters? Yes. Okay, create name, edition, src, error format, diagnostic, create type, debug info, metadata, extra file name. So nothing special, right? Nothing special, just create type and probably edition. Okay. Let's try to add it here. Sleep, create type bin, probably edition. Well, let's start with edition. Edition 2024. Yeah, we specified edition and now it's changed. Okay. So what went wrong? Okay, because it's cchar. Should be cchar. Nice. It's used. It's used. And this one is also used. Not necessary. Okay. Seriously? Okay. Actually, unsafe. No mangle. No mangle. Mangle. It's another one we need to apply. Okay, now we have only warnings. Now we have only warnings. We can fix them. One. Then this one actually will crash. Okay, now we have fixed these warnings. Nice. We have only this one. Let's start. Let's proceed with it. So for arcs, we need second one, right? First one, starting from 0. Let again same stuff, but arcs get this one. Okay, there is no such method. We need to parse it. We need to get reference to str from this, but to do that we need to validate for x validate that this is correct UTF-8 sequence. To do that we can use let's say this one, core FFI. Now it's C string. What's method it has? Rust C string. It has from bytes until now. Yes. Okay. From bytes until now, we need to pass here. Oh no, it's pointer. It has from pointer. This one. We need from pointer. From PTR, sleep, duration. Let duration C string. It's unsafe. In newest edition we have to specify unsafe, even our function is unsafe. After that we can access, we almost can access string underneath. Let sleep duration a little bit to string lossy. Duration C string string sleep duration C string to string lossy. Nice. And now we can parse it finally. Right? Trying to build. What we have here. Okay, here we have some minor type mismatch. What's wrong again? Okay, now it compiles. Now it compiles. More unsafe, yeah. More unsafe. Unsafe, inside, unsafe. Okay, we one step closer to NastyD build. Let's explore what we have right now after that. Okay, we build it, we run it, sleep. 2 seconds. Still works. Oh, no, too much. Something like this. Marshall be integer. Okay, it still works. Nice. Actually, we need to check that echo failed. Yes. So error code is correct. We returned some non-zero error code. Nice. Okay, let's check. Let's build it in some optimized mode. -03. And after that, you don't know what is 03? 02? Seriously? Okay. -c opt level 3. By. What's wrong with you? Rust C ---- help. Help. Okay, okay. Without this. So now if we check what we will have nm -s sleep. We have still a lot of useful symbols. That's fine. But we still have, we still have a main, right, as our entry point. Okay, let's go next step and use actual entry point start, right, instead of main. So it will be same. Unsafe. No mangle. Also it will be unsafe following the reference implementation. Naked. Right. Extern C underscore start, right? Check if we have everything fine. Fine, yeah, fine. Naked function must contain single naked ASM invocation. That's expected. And unlike C, it must be only single entire block in ASM which contains the entire body of the function. In C, it may interleave and producing some undefined behavior. Naked ASM. let's now go back to our reference implementation, right? What we have here. Yeah, which parameters should be passed here? It's explained in this great video, not in mine. This one is not great, but we just need to copy it and slightly rearrange, because by default in Rust used not AT&T syntax but Intel syntax. So we just need to rearrange it. And also it doesn't use all these percent signs. So we don't need all this stuff. DI, RSP. Different, right? We need to move RSP to RDI, right? RDI to RSP, right? Then we need to low effective address in RSI. RSP plus 8, right? This is how it works. Probably like this, right? I may be wrong. And gain RSP. Not sure about this. It's AT&T magic, but we can minus 16. Maybe use it here. Call main, move wait. We need to move it. Let me go back to this code and manual. Yeah, if I remember it's right, it should be inverted, right? So is it correct now? Let me find it. I'm just not writing. I just don't write inline assembly every day. Okay. It's a binary interface. Start. Main returns exit value, pass to exit, and it has to be overridden by returns exit. Yeah, MVP here. Argument count in RSP. But we already returned, so return should be in RAX. Why we move it here? Okay, I got it. We are going to we are calling exit, so that's why we're moving it. Okay. RDI, move RDI, RAX. Yeah. So yeah, in Intel assembly arguments are reversed. So, well, in Intel assembly it's in normal order, but in AT&T they reversed. And we move RX to RDI because we need to call exit. Yeah. So now if we build it, what we'll have? Okay, we have some issues because core naked ASM provided by some module, right? Let's find it. Which module is it? Core search naked ASM Arch. Naked ASM. So it's core Arch. And also we don't need this /n. Okay, let's go. What we have? Duplicated symbol. We just need to disable this default start. Okay, we can. No start. It's minus. Start is linker parameter, right? So it should be minus VL, I believe. This means no start files. UCC, no start file, request the command line. Why? Wait. Let's see, sleep. Okay. Rust, no start. Channel core, generic function, lang start. And since it requires nightly, no. Okay, start is a language item in Rust. Looks like, and it requires no core. So we cannot define start function without some extra steps. Okay. Is it possible somehow to overwrite start feature? That's for panicking. Okay, I see. Okay, I found it. So yeah, we need to pass no start files parameter somehow. And this is a workaround. And this is a workaround. So we cannot pass it parameter to rustc directly, but we can do this. Okay, let's do that. Bam. Actually, externc we probably can even pass it here. Do we need these modifiers? Maybe not. Can we live without them? Let's try. Okay. Okay, it cannot be used as this. So this is the right way, unfortunately. It's unstable. Ah. Link arc is unstable. rustc bootstrap? Maybe. I don't want to do that. Rustc pass link flags. Is there any other option to pass link arguments? Well, you can instruct cargo to pass this flag, so it should be possible. Yeah, it should be possible to pass here. Let's try. Let's try. It should be possible. So -c link arc. No start files. Yeah, it works. Okay, so it's still possible. Maybe it was stabilized in some of recent versions. Okay, so can we now run it? No, we already escaped nightly. Everything is fine. We can live without nightly. We just need to pass this argument in some alternative way. And that's fine. So if I did everything correctly, I hope I did everything correctly, but I'm not sure. Segmentation fault, nice. So yeah, something is broken here. Something is broken here. Most likely something this. Something like this is broken here. So it's time to debug, right? GDB. Sleep. Run. Yes. Segmentation fault. Where? BT. Okay. Instrlen. Nice. Okay, so everything's fine. We just messed up with some of these parameters. So let's go back to the to reference implementation. So it's moved to where? In AT&T syntax, this is taken the address, right? So this is broken, right? This is broken. So I should move to RDI. This one, right? Maybe -16 is not this one. We can check. Yes. Yeah, now it works. So this one was missing. So yeah, these curly brackets in not curly parentheses in AT&T is yeah, dereference kind stuff. Sleep 5. 1, 2, 3, 4, 5. 5. Yeah, it works. Nice. Easy clap. Yeah. So yeah, everything's working here. Nice. We can proceed with eliminating some other parts of Rust. Nice stuff. So now we can do something like this. No std. No std. And let's check what we'll have here. Now we have a lot of errors. Again. Try again. Can you not mess up my terminal? Shitty. So if I rerun it again, it will be better. So yeah, no method found in CString to string lossy because it allocates potentially. Allocation is not available in NoStd mode without alloc crate. We are not going to include alloc crate. We need to use something different here. What else we have? Duration is provided by core. Nice. So use std, oh, not core, time duration. Nice. What else? Thread sleep, we will replace it, of course. We have to please. Println also is not available in NoStd mode. We need to replace it. Yeah, nice. Nice. Let's start one by one. So again, compile. Let's remove first these two string lossy. What we can use instead of it. Actually, we don't need to use anything. We will need just use something like this to string. It may return error. Okay. And otherwise, else, again, let's insert some println, which is not supported right now. But okay, let's disable NoStd for a moment. Println. I don't work with non-UTF-8 stuff. return error. Well, non-UTF-8 string representing integer, it's something strange. Anyway. Semicolon. Okay, still compiles. Now return noStd. Okay. Now we need to eliminate all this print and thread sleep. Okay, let's start with prints. Again, we can follow the same reference implementation. Yeah, we will need some wrappers to execute these calls, right? And for print, we can use write this call, right? So let's go. So which one we will need? syscall3. Yeah, copy syscall3 and rewrite it in Rust. Can I close it? It's distracting me slightly. Okay. Fn number is we can use eSize or E64. It will be less portable. E64. Or we can use CLong. We have it. Use core FFI CLong. It should be there, right? Doc.rs. Ouch. Second. Rust core documentation. Again, search for long here. Do we have it? Yes, we have CLong. CLong. arg1 CLong. arg2 also CLong, right? And arg3 again CLong. It's unsafe, of course, but now we don't need extern C anymore, at least. Here the same. Let result, it should be CLong, and return CLong, right? CLong. Again, core arch awesome syscall, and here Rust provides something similar to specified parameters for input and output registered mappings. So we can do, let me open documentation. Rust awesome inline assembly. It has a lot of funny part. Let's go here. So yeah, after assembler template, it has list of parameter mappings. We will need in out, in probably, and late out. So let's start. First of all, we need late out. How again it's written. Register equal something, right? Yeah, register something. Yeah. So late out RX, right? As input we put number, right? As output we return it into result. What else we need? We need in D capital, it's RDI, right? RDI is let's return back in out. Template string arguments, 1 second. Yeah, in, out. If in RDI for arc1, we need in RSI arc2, and we need in for RDX, right? RDX arc3. It also has RCX R11, right? We also need to specify them, unfortunately, as input. But in here also add some requirements that the SM code should not after completion of the execution should not leave the register modified. And yeah, we just need to specify them, like in out. In out also says that it should not be modified. RCX, and we ignore it, or just out. Let me find the example. I messed with this. Should it be in out or just out? Well, it definitely doesn't modify it. It doesn't provide output in this way, but still need to confirm. 1 second. This guy. Late out. It should be late out. Interesting. Late out. R6. So it may be modified. And late out. So. Okay, and some options. And unlike GCC version, we provide some options that doesn't tell that we are going to modify memory. There is opposite. We provide some options that says we are not going to modify memory, or not going to provide, not going to modify stack or what else. So syscall can modify memory. That's why we don't need to provide any options regarding memory, but we need to provide options for some preservation of signal flags like carry flag, and also you need to say that we are not going to modify stack here. So it's provide like options, no stack, and preserves flags. Yeah, looks like yes. And we don't need this return, we can just put it here as a result like this. No, now should be fine. Now should be fine. So there's some fun differentiation between out and late out. I'm wrong. It should be in late out, because we provide some input value for register RX as a number of syscall to be executed, and result put it in back in register, right? So there are some funny mechanisms in Rust annotations for this inline assembly that if it's just in out, it should be different registers, and input register should not be modified. It should not be left modified. It should be rolled back to the original value. But when it says in late out, it says that okay, input register can be modified. Okay. Try to build first what we have. Unsafe function is called, its body is safe by default. Okay, it requires unsafe. Add unsafe. I agree. We need unsafe. Here. Why it's so slow? Okay, now we have new errors. No, we haven't introduced anything new, except we have noticed this another funny error message that in noSTD mode we also need to manually specify panic handler. So let's do that first. Somewhere here. Panic handler. It has signature following on panic. Name can be arbitrary. Info. Let's ignore it. So it's core panic info, and this one should not return. We can use never type in return position. It's stabilized partially. It partially stabilized. Loop, for example. We are not going to panic. Try to build again. Okay. Unwinding panics not supported without std. Why? use nightly. Why we don't need to use nightly? We need to just specify panic abort. How to pass it? Rust C panic abort. -C. Nice. Just -C. -C panic abort. Nice. Okay. -1 another error. -1 another error. So okay, we can proceed with eliminating our prints. Okay. Write syscall is number 1, right? Right. Const sys write is clong 1. Define write and save. No, now it's safe actually. It's completely safe. Print fn print. Here we pass anything that implements as bytes, anything that can be interpreted as bytes, raw bytes. No. Just this. As string unsafe syscall 3. We pass here syswrite, right? Then file descriptor, it's stdout, it's 1, right? 0 it's std in, 1 is stdout, 2 is stdr. And here we need to pass pointer, right? As ptr. And you need to cast pointer to integer. How we can do that in Rust? It's not easy to do. It's not just cast. It's not just write to as something else. Rust pointer. It has method address. Yes, we need to call address. Address, and here is clong. And the last one is clem, and also as clong. It returns something, but we can ignore because we can. And here we now can replace it. Print also we need to pass some /n /n. Nice. Okay, we have only this one, last one, sleep, right? Also, we have exit that provided by libc, no? Because we still linked against libc, right? If we right now again return back no std and comment out this panic handler temporarily. Yeah. So if I run LDD against my sleep binary, what I see? Yeah, I see we still have gccc and libc. let's start again here. We can add another C-link argument, no std, no libc, right? C-link arg, no libc. It's still here. Why? Rust C, no libc. What I have missing? But it's still linked again. Okay, they said that if you are using NoSTD, it doesn't link against libc. Okay, let's temporarily disable this. And this. Go back. What's wrong? Nice. Nice. Okay. So now with no std, no libc actually works. Otherwise it's ignored. Nice. It's so convenient. Huh. Okay, okay. Undefined symbol exit, undefined symbol strlen, Rust EH personality also undefined symbol. Why? Why this guy is undefined? That's interesting. Okay, with this one and this one it's okay. Because sister calls strlen, we can avoid that, and we must write manually. We have to write it manually. But this is actually strange. Why this one is using strlen? Why it's not written manually? Why it's not re-implemented in Rust? Okay, let's start with exit. It's easier one. We need syscall1, right? For exit. Boom. Syscall1. We need to remove these two arguments. And we need to implement exit. Unsafe. No Mongo. Extern. Unsafe, extern. CFN. Exit. It returns nothing. Syscall. Unsafe. Syscall1. Exit. Code C int. Code as C long. And what's the error? What's the... Okay, 60. 60 const sys exit c long 60. And similarly to the C version, we need some loop here. Let's compile and see what we have after that. Oh, sorry. Sys exit, right? Actually, exit now completely safe. We have strlen undefined symbol. We can define it. And we have Rust EH personality. What is it? Why it's here? It's just referenced by Rust by core. Okay, let's deal with strlen first. Well, we can provide it, or we can just replace our from PTR. Let's just replace our from PTR and save from fn bytes from now terminated. Here we have PTR const cchar returns u8. So, and we actually can assume that it's not null. Actually, let's do that. Let's do that, because we know that this one is not null. Use core. Where is this? It's not null in core. Core. Search non-null. Yes, core PTR. Use core PTR non-null. Let's bring some safety. This is Rust. There should be more safety. So here we know this one is not null. Non-null cchar. And this one is also non-null. And the only problem is here, but that's fine. We can easily work around it. We know that argv, first argv elements definitely not null. We can just cast these pointers. Argv as const non-null cchar. Let's go. Is it still can be compiled? That's fine. Okay, just complete this. And now we can have this counter. Let's begin. And then cursor, right? Right. While cursor which methods we have on now to read it? Make it as close, please. No, now. Core PTR no now. Other offset cast copy get from mute dereference no dereference read. Does it have read? It has write. It has read. It has read. It has read. So we can use while cursor read is not 0. Cursor add add, yeah, cursor add. Yeah, in Rust there is no address arithmetics directly with overloaded operators. We need to use methods, safe methods provided by std. And it's also unsafe, right? It's all unsafe. It's safe. And after that we need to compute distance is byte offset count and the distance it's cast array nightly, everything's nightly, check offset from, yeah, offset from. Yes. Offset from. Also unsafe. Interesting. Why just pointer arithmetics is unsafe? Safety. Master использует same address. Okay. Okay. Yeah. Because pointer arithmetics is not defined if they're not pointing to the same location. Okay. So after that we return safe. Let len is unsafe. Cursor offset of ptr, right, and cast it to size, to usize, and that's all. Now we can just core slice from raw parts ptr sptr len. Remove this. This replace this with our new function from bytes from null terminated. Bam. And here we can call duration bytes. We can cast it to string. No, not cast, we can create a string reference from it performing all checks. std, not std, core str from UTF-8. Actually, core not needed here, just str. Try to compile. No. More errors. That's fine, we can just cast here, cast EU8. Why there is no offset? Off? Why there is no offset off? Offset from. From. Boom. We have more errors. Oh, ADD doesn't mutate. It returns newer. Okay. Interesting. Cursor. Duration int. Underscore. Okay, what we have here? More unsafe, right? More unsafe. This is actually annoying. That I have to use explicit unsafe block inside unsafe function. Semicolon. Okay, now we still have a strlen. Why? That's interesting. Why we still have a strlen here? Maybe because of sleep. What? Yeah, most likely because of actual transformation that compile did. Can I remove opt level, please? Opt level 0. Yeah. Yes, you can see that I removed optimization and now it doesn't complain about strlen. So that scene that I actually tried to reproduce at the start of the stream, to show that compiler can replace the function that looks like some standard function with call to the actual standard function. We see it here. Compiler replaced with optimizations. Compiler replaced this body with call to strlen. Okay, now we need to just fix this Rust EH personality. It's again some stuff for Panic's handling. How to do that? I just need to search. We probably just need to provide some definition for it. Unexpected. What we need to do that is that. Yes, we provided panic handler. And okay. Precompiled standard library is compiled with panic and wind, and this reference blah 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 blah. If you compile for track which how we can recompile do I need nightly again? Rusty means C panic abort on your own crane will use not only but static leap. So we just need to recompile core with panic behavior set to abort. Nice. How to do that? Actually, I know how to do that. Well, I know where to check how to do that. Rust minimal, and then this is not a ChatGPT. Binary size. There is nice GitHub repo which showcases how to minimize binary sizes, and it also has some special section mentioned how to recompile standard library, how to opt out it, how to do something else. Okay, this one. You need nightly. You need nightly. You need nightly. Nice. Can I do that without nightly? Or can I provide this EH personality? No std. Present error. EH personality again. Lip start we know. We know this. We already fixed it. Create type. So it requires nightly. It requires nightly. Or there is some parameter cargo profile def panic if I use cargo. But what if I don't use cargo? Will it work without cargo? Interesting. Nope. What if Rust C? Rust C. Nope. Any other parameters? How to do that? How to do that? That don't depend on libc. Okay, what other flags do we have? Or we can just define it. Yeah, let's just define it. Rust EH personality. Where is defined? It's lang item. Nice. But can I somehow define it, provide it? It should be possible. What's it? Its definition. How it's defined? We can probably find it in Rust GitHub. Maybe here we can find it somewhere. Each personality. Okay, it's a function with the similar signature as we had. Okay, let's try to define it. We can. So just Rust EH personality. Okay, let's do that. No, Mongo, unsafe, fn, gain extern c, fn this, nullity returns nothing, loop. Okay. Okay. What about dependencies on libc? It should not be anymore. And we don't need this environment variable anymore. Well, it actually doesn't work. It actually doesn't work. Okay. LDD. Sleep. Statically linked. Nice. Nice. So now we need to just fix our well, we need to get rid of this sleep, and that's all. We are done. We done. So yeah, for sleep we can just copy our reference implementation, right? So we will need this time spec. We can define it internally. So we need for sleep syscall2, right? Yes, syscall2. Let's rearrange slightly them. So syscall2. And remove argument, right? Nice. And now we can implement it. Let's do that. We don't need externc here. We don't need unsafe or mangle. We can just write fn sleep. Fn sleep duration. This one will be much more powerful than one provided by the reference implementation. Duration sleep. So we need the structure, right? Struct time spec. It should be represented as a C structure, repr C. And what's parameter we need here? Two longs, tvsec, tvsec, and tvnsec, clong, tvnsec, clong, right. So now we can fill it. Should it be mutable? No. In sleep, no, it shouldn't be mutable. So let ts time spec tv seconds, its duration as seconds, right? Let me go to documentation to check duration. So it has as millis and secs as so. Okay, we need nanoseconds. tvnsec. Actually, we can do this, right? In tvsec 0, right? And tvnsec duration as nanos. Cast and just invoke. So for sleep it's 35. Const sys nano sleep clong 35. And call it unsafe syscall 2 sys nanosleep pointer to time spec to TS. Actually, there is special syntax, right? Raw const TS as this one and post pass 0 here. That's all. That's all. That's all. We can call it here sleep. Let's compile. What's wrong? Okay. Just some minor type mismatch. What else? Okay. Sleep duration int, some unused variable. Okay. What another? 90. Another one. Nice. And now let's try to build it. And I try to run sleep 1, sleep 2, sleep 3. It doesn't work. It doesn't work. Why? Should there be remaining nanoseconds or? Let's check. Let's check it. Man. Sleep. Nope. Man 7, right? Sleep. Man 5. Oh, where is defined? Sleep. Sleep 3. 3. Okay, this 1 seconds. Nano sleep. Nano sleep takes duration here. What duration should contain? How it should be defined? Okay, this one, right? 2, 3, 1, 2, 3. Yeah, it should be remaining nanoseconds. Okay. Let nanos this should be diff mode. Do we have diff mode? Diff mode rem Euclid diff Euclid I want to divide at the same time. No, not such. Okay. Const second is u1 to 8. It's 1, 2, 3, 1, 2, 3, 1, 2, 3. Right. So as nanos let seconds is nanos divided by second. Let nanos divide by second. TV speak 6 sh and nanos is this one. Yeah, that's true. Well, we don't need to fight with borrow checker here. We're not dealing with any reference, almost any reference here. We operate on raw pointers. If you operate on raw pointers, you don't need to fight with borrow checker. Here we fight with here we're fighting with yeah, potentially nightly features. Okay, we work around it, all of them, and also the last one will be to deal with this replacement of common patterns with standard library functions. It's actually strange why Rust did that. Because it immediately makes well, just imagine you change the optimization level and your statically linked binary became not statically linked binary, because now it depends on libc. Just because Rust compiler, not Rust compiler, well, Rust compiler just created some intermediate representation for LLVM, and the LLVM decides that, okay, I need to include some standard library function. It's insane, it's nonsense. Okay. So now it should work. Let's try. Where is it? Build. Some unexpected tokens, some commas missing, right? While parsing this struct, yes, some comma missing. Okay. Now sleep for 2 seconds. 1, 2, 3, 4. Yeah, it works. Looks working. Looks working. Now. Now let's deal with this last problem. That okay, now everything works without optimization. We enable optimization level to level 2, and it now complains about strlen. That's okay, but we can fix it. I believe we can fix it. I believe we can fix it. Maybe some kind of no built-in. Is it link flag? No, it's not link flag. Rust no built-in. Compilation flag. Conditionals, CPU target native. So if I go back here, so can I reproduce this? If I switch to, yeah, if I switch to LLVM, Clang. x86. Yeah, let's use trunk. O3. No, O2. Interesting. Clang doesn't create such shit. Rust C flux. Which flux we have? Which flux we can try? Configure H minus L minus input modifiers. Okay. We don't need. Create type we don't need. Addition okay. Okay. We don't need it. Optimize. Explain. Test. Target. Force warn. Settling denied. Second version. Verbose extern. Sysroot. Diagnostic JSON, nothing useful here. GCC no built-in. Is it link flag or not? Shouldn't be. GCC F no built-in. F no CD elect options. F no built-in. Don't recognize. So it's not a linker flag, but we can still try. We still can try. Minus C, F no built-in. It's not recognized. So yes, this is fun stuff. Why it does this shit? Why it does? Is it mentioned anywhere? Rust C replaces code with C function calls. Rust C. Maybe it's a bug report potential. Sterling. Yeah. Okay, something related to old version. Extremely old version. 10 years ago. How we can work around it? Any suggestions? Actually, how it's implemented in in core. Let's check how it's implemented in core. Just in case. Core. But yeah, this looks like a potential bug report. This should not happen. I will write bug report for RC. So if I check cstring, let's go here. Let me open it here. So cstring, it has from pointer, right? From ptr. How it's implemented? Let's go here. Oh, it calls strlen. Okay. It calls strlen. This is strlen. And this strlen implemented in Rust. But when you enable high level of optimization, this implement. Okay, yeah, I see. Else it has version provided by libc if when. Okay. So actually it uses version provided by libc, but only in not const-eval context. Okay, so this is maybe expected. But this shit. Okay, we can fix it in the same way. We can provide our own implementation of strlen. But this will be fun. Right now we will see exactly this undefined behavior I tried to show initially. If I provide right now implementation of strlen, compiler recognize that this is implementation of strlen, replace strlen, and produce the infinite recursion. Let's see. Let's see. Unsafe. fn. Oh, is there any attribute which can disable optimization for particular function? Rust disable optimization for function. Is there any attribute? Nightly. Nightly again nightly. But okay, let's demonstrate it. We write and save fn strlen and save extern c. Maybe I'm wrong. Maybe it's smart enough to recognize it. Okay, don't touch it. Unsafe. No mangle. Strlen. We can take here non-null cchar. If you pass null pointer to strlen in C, it's an undefined behavior. It should not be. It should not be null, but we can explicitly say it in Rust. Char, and it returns usize. So here we can Copy this. Bam. Return it. Unsave strlen. Here. Compile? No? What's wrong? Oh, okay, yes. Yes. Why it's okay. Closing. Huh? Okay. And now? Sleep? It works. Okay. It works. It works. It works. Oh, it doesn't. 1, 2, 3, 4, 5. It works. Nice. Okay. Say that students provide it's memory component from LVM. Yeah, it's most likely. Or you mentioned you where is it? By libc or compile built-ins. Well, maybe for some. Well, it's not necessary for platform with libc present. It may be for some other platforms where it's actually provided by compiler built-ins. But here it tries to find it from libc. It tried to find in libc. But okay, we did it. So actually, Rust compiler is smart enough to not try to optimize it via replacing by strlen and producing infinite recursion. But this is fun. If I remove no mangle, it again tries to find strlen. Tries to find strlen to replace it. That's fun. Okay, so what we have after that? LDD for sleep. It's statically linked. Nice. NM -s for sleep. Go away. Nice. We almost don't have any weird symbols. Just this core string from UTF-8, but that's fine. And convert from UTF-8. That's also fine. Nice. And let's check one more thing right now. Let's check one more thing. So if now, okay, let's mv this sleep as sleep rs. Let's compile GCC. Event not found. Why? Boop. Right. Seriously? Okay, maybe it's some another terminal. But okay, let's build it again. GCC -oats nice O sleep C minus O3 minus no lib C minus f no stack protector and f no start files, right? Sleep C. Run it. Sleep C. Yeah. 2 seconds. Nice. It works. LDD sleep C. Not a dynamic executable. Okay, statically linked seems. Oh, okay, wrong. Statically linked, nice. And let's try again, but with C++ version. CPP. Now it's C++ version. Again, CPP. CPP. G++. Sleep CPP. 2 seconds. Okay, still working. And LDD sleep CPP. Statically linked. Nice. We achieved what we want. What we wanted, right? So now we can compare them all. ls minus li. Let's rebuild Rust version. I just forgot which compile. Opt level 3 I want. Opt level 3. Sleep rs. Okay, let's be fair. Let's use the same naming convention for all of them. Delete this guy. And now we can check. ls minus la. Here, sleep. All these guys. Rust version is large. But that's fine, because it contains debug info. It contains debug info. Let's remove debug info. How to do that? It can be passed again. Rust minimize binary size. So there is a parameter. Where is it? LTO. Abort and panic. Remove local defaults. Against requires nightly. That it can be debug false passed, right? Let me try. Minus C debug false. No. Repost to there. Strip. Not true. Okay. Strip debug info. Okay. Okay. And now the Rust version is smaller than C++ and C version. And it still works, right? Sleep rs 2. Yes, it still works. Okay. If I use here symbols, it goes even further. Debug info. Yeah, that's all. That's all. It works. So, what we can do with this? Okay, we need to leave some comments and finish on it. We need len because Rust C on opt level 2 plus tries to replace any string like code with strlen call. Okay, nice. I actually right now don't know how we built them. Right now I don't know why the C version and CPP version is slightly bigger than the Rust version after that. I don't know. We can compare them. But this is fun. Well, okay, maybe just because of some symbols. Let's strip them. Let's strip them all. Lib C. Strip sleep CPP. It's still bigger than the Rust version. I don't know why. How we build them? O3, no libc, no stack protector, да? Okay. What if we again check the symbols? nm minus s sleep c. Okay, no symbols, right? Yeah. So here we have 1, 2, 3, 4, 5. CPP. Same. Strlen. Well, I don't know. If anyone knows why You can tell me. Maybe if we compare generated assembly, we can find that, okay, somehow. Okay, I know. Okay, I know. I probably know. Just because this one is GCC, another one is LLVM. Let's try to be fair in this competition. Let's build it with Clang. And now if you strip it, nope, it didn't help. Okay, anyway, we achieved what I wanted. We have exactly same implementation for almost same implementation, except maybe in difference of this one from UTF-8, which uses some Rust core parts, and we're also still using some, well, Rust core is much more rich and feature complete than the just plain C language, right? So that's fine. We can go even further. We can go into no core mode, and this will be fun. Actually, what happens if we do no core? Boop. So with no core, we need some lang items, and these lang items looks most likely cannot be defined without nightly. Requires sized lang item. Okay, is there any manuals for no core? Rust unstable book. But why do you need no core? Maybe for some extremely specific platforms only. But yeah, no core is completely nightly feature. Yeah, how to build with no core? You need unsay. You need features, feature. Yeah, and if I scroll up to the beginning, no. Okay, yeah, no core requires nightly. We are not going here. So what we found, I actually didn't know that before. That because this knowledge is completely useless. No, not about assembly, but what I actually want to say, that if you try to build no STD version of your code, if you want to access core crate when you're building with STD, and if you just use rustc directly without cargo, it it doesn't work, it requires you to explicitly specify addition. Otherwise, it doesn't work. It says that I cannot find the cork rate. And other stuff that, oh, okay, yeah. A lot of stuff requires nightly still. Yeah, we were able to achieve our humble goals without nightly by providing some stubs like this Rust EH personality. It should handle panic, right? It's some another stuff which handles panics. It's exception handler, panic handler. But for inline assembly, yeah, we have everything right now. Almost everything, maybe some weird feature is still missing. But for just direct usage of syscalls, yeah, everything's here. So that's why maybe slash crates like Rustix right now can drops usage of libc crate, which provides just bindings to just wrappers, not wrappers, just bindings, just bindings for C functions in Rust. Yeah, for C functions from libc in Rust. Okay, they can directly call syscalls and maybe face the same issue with strlen. Or some other stuff. Another fun function is memcopy, right? Memcpu and memmove. Most likely, if you try to implement them, you'll have the same issue. But yeah, that's interesting. Actually, let's try one another stuff. Because even in Compiler Explorer, I cannot trigger this funny undefined behavior. Let's try it with memcpu, because for memcpu it worked. So if I implement memcpu in Rust, will compiler shoot us? So if I do, let's just double check that. Let's go GCC x86 trunk. So if I implement memcpu, so memcpu returns what? Void char memcpu void dst const void src long unsigned long size. So if I implement it here, so counts down char dst const char src c for unsigned long I less than size plus I dst ci equals src ci, right? And returns src dst. So if I compiled -3, Nope. Interesting. If I add attribute no inline, attribute no inline, nope. Some previous version did that. No. Nope. Okay. Okay. It didn't work. But that's fine. Okay, we can stop on it. Let's was enough time spent on this exercise. I probably create a new branch and push it somewhere. Okay, let's do following things. We need to rename it back. Sleep-C. And remove all this garbage. Delete. Nice. We need build commands. Copy readme. Build. Boom. And another one for GCC. C. GCC. Yes. Copy. Yeah. So yeah, okay, we can use this and just git. What's going on? Why it's again it's lagging? Git checkout -b Rust version git add readme git add sleep-C sleep-RS status commit sam add Rust version and build commands. Can we push directly? Is it protected? No? Gen Rust version. Okay. Okay, I can fork. Let me fork. Unprotected. Fork. Create. Code. Git update origin. Git remote update, right? Git remote update. Set URL. Git remote set URL origin this one. Git push origin Rust version. Okay, I pushed it into my fork. Anyone who wants to play with it, maybe someone wants to do that in, let's say, in Zeek. Well, in Zeek it's easy, should be easy. Just copy paste. In Zeek, maybe in what other potentially compiled language. Theoretically, it can be possible in Go. Maybe in Go, if you disable garbage collection, it should be possible in Go. And then what other? Swift. What other language can do that? Odin. Any others? Jai. Okay. But it would be fun to see implementation in Go. Build statically linked, completely statically linked binary in Go without garbage collector that calls sleep syscall. It should be fun. Okay. And I believe that's all. If there are no other topics, I stop on it, maybe. That's fun. Yeah, I'm not a great how it's called, entertainer, yeah, but we did what we did. Okay, yeah. Thanks all who joined with such short notice period. Bye.